And now let's see what we found out with this investigation. We have what is called a distribution here, and this distribution is named Benford's distribution because unlike the ones we saw before, this one has a highest number of ones, then twos, and so forth. Benford was a physicist who discovered it in the beginning of the 20th century, and he saw it naturally occurring in places like death rates, lengths of rivers, population numbers, and so forth. We bring one example from finances. Namely, here we have financial state of a country. Let's say that country's GDP, or gross domestic product size, is €1 in the first year, and it grows by 10%, which means that it's 1.1, which is 1 times 1.1 in the second year. Furthermore, third year grows 10%. It grows by 10% again, which means that in the end it's 1.21, which is 1 times 1.1 times 1.1. And we see that we have actually taken 1.1 to the power of 2 here. In the third year, in the fourth year, it's 1.331, which is 1 times growth in the second times growth in the third times growth in the fourth, which is 1 times 1.1 to the power of 3. Which shows us that if there is a continuous growth of 10%, we can actually move to another year by just taking 1 times 1.1 to the power of the number of years. More specifically, if we go to the fourth year, it's the power of 3. If we go to the fifth year, it's the power of 4, and so forth. Okay, this is growing. This is when an economy grows by 10% constantly. Here is actually the general formula. Nth year GDP equals first year GDP times 1.1 to the power of n minus 1. If the nth year is 10th year, then the first year is multiplied by 1.1 to the power of 9. Okay, so we have economies which have grown like this. For instance, China has grown tens of years with such a growth rate. But let's see what's going to happen. This is called exponential growth, which means that the growth is really rather quick. If we have a 10% growth every year, then think of what's going to happen if your economy has size 1, and it needs to grow a lot until size number 2. Until size 2. This growth here is 100% growth, so it takes a while. Now let's say that the economy grows further until it reaches 8, and now needs to grow until 9. This growth is only a little above 10% growth, so if this growth went really slowly, this growth goes rather quickly, and we reach 9. Now we reach 10. And we need to reach 20, and this again will be a 100% growth, which will be slow. Next up, we will grow until we reach 80, and then we want to reach 90. So this growth will again be little, because it will be only a little above 10%. So this grows quickly. So once again, if our economy starts growing, and it starts growing from 1, and it grows to 2, this is 100% growth. So 1 is the leading digit for a long time. Now it grows to 2, 3, 4, 5, 6, 7, 8, and now for instance from 8 to 9, it grows only by 10%, which is quick growth. And 8 is a leading digit for a short period of time. Now it reaches 2 digits, which is 10, and to 20 it grows for a long time, and all that time from 10 to 11 to 15 to 16, 1 is the leading digit again for a long time. Then it goes to 20, 30, 40, 50, 60, 70, 80. And from, for instance, 80 to 90, the growth again takes little time, because this growth is only by a little more than 10%. And so it continues. One more step. It reaches 100 until it reaches 200. It takes a long time because it's a 100% growth. Then it grows to 300 and so forth until it reaches 800. And now from 800 to 900 this growth is rather quick because it's a 10% growth only. And we reach 1000 and so forth. So that's how the system goes. So once again, if we have exponential growth, if we have growth which always brings us, every new year brings us a 10% growth, then this is what's going to happen. Exactly Benford's law. From the leading digit 1 to 2, here and here and here, we get a very long growth. And from leading digit 8 to 9, for instance, we get a short time span. Okay, so this is what is present in financial numbers as well. And here are a couple of faces. Bernard Madoff, who actually came up with the biggest Ponzi scheme in history, and who, when he forged his numbers, actually did use Benford's law. So he knew he'd be scrutinized for that distribution, and when he created his false numbers, he used Benford's law as well to not get caught. As I said, the scheme was called Ponzi scheme. This is actually Charles Ponzi, who in the beginning of the 20th century came up with a scheme of his own. Well, then they didn't look for Benford's law yet. And another little bit is from Financial Times, which says that the Benford's law was not actually, I mean, the strongest deviation from Benford's law from the countries who started using euro in around 2000 was actually by Greece, which is in the last years has been having very steep problems in economically. So once again, this article states that if Benford's law had been more the numbers following Benford's law had been more thoroughly investigated at that time, perhaps we would have caught up to Greece's misdeeds earlier on already. And what we've done here is we have discovered Benford's law in our numbers. We have used frequency, array function, and kind of really gotten some insights from our data.